Hello, welcome to Computer Science 220, part two of the review for the final exam. After the regular review wrapped up, I got a few questions via email. So this video covers the um, answers to those questions. The first one is about throwing exceptions. And the question is about what if I don't know what type of exception I should throw in a particular program? And the great news for that is that Java has you covered. Um, Remember, we talked about inheritance. That's one of the relationships that can exist between different classes, different data types. And we talked about it in the context of the object class. That's the class that is at the root of all of the inheritance that can occur within Java. So it's like the grandfather or grandmother of all the classes that exist, whether they're classes that are part of the API or classes that we write, like student and movie. There's also a generic class in the standard API that is called exception, and it is the grandfather, grandmother root class of all of the different types of exceptions that exist in Java. And when you define something to have that root data type, hold on a minute. Okay, I'm back. That root data type, whether it's object or whether it's exception, it can get replaced by any more specific version of that data type. So for example, if we declared a class that stored a list of objects and we set the data type of those objects to be the object class, that root class for all Java classes, then we can substitute any more specific version of a class like student or movie or string or the any of the wrapper classes like capital D double, anything like that for that object type, because all of those other classes are objects. They inherit from that more specific root version. Let me share my screen for a minute and we're going to look at the Java API, specifically about exceptions. Let me try to find, here it is. So I pulled up the Java API about exceptions, and you can see the generic root class exception. All of these specific classes down here, these subclasses, those are classes that inherit from the original exception class. So if you get a exception like file not found or something like that, that's a exception type that inherits from this original exception. It can be substituted anywhere that our code specifies that an exception is expected. Because these are more specific kinds of exceptions, they can replace that original generic type. And we've used that idea in our programs in the past. Um, pulled up our example of the student class, the original object-oriented program data type that we created together. We got our data fields in there. We had some constructors. We had some getter and setter methods. So this is just the version that we wrote together in class. I also have pulled up a main program that makes an array list of type student. It reads in the specific data values for one student, bundles them together as a student object, and then adds it to the array list. Let's look at more detail at one of the methods in the student class that we wrote that uses an exception. So we wrote our set GPA method, so that if the person using our data type calls set GPA and passes in a bogus GPA, something that couldn't possibly be the person's GPA, then we generate an exception, and we use that generic exception type. And so what we're telling the computer is if the value that they pass in as the parameter is in range, then we're going to use that to set our GPA, the data field in the class. But if it's not in the range, then we're generating a new exception. That's just the generic exception class We're not saying it's a specific kind of exception like file not found or array index out of bounds. We're just saying it is an exception, it'll get generated. We didn't do anything to check for that in our program. I didn't call that method in this little example program we got going on. Let's add on to this example using one of the methods that does get called. So we're calling the constructor for the student class in here. Let's add an exception to the student class non-default constructor. So I could do the same kind of thing. I could check to make sure that the GPA is in range. I could also check to make sure that the credits are in range. So I could say something like, if the credits that they pass in as the parameter, if those are bigger than or equal to 0, then that's cool. That means that that's a possible value, something valid to set the credits to. But in other cases, if they give me a credit and it's negative, then I want to throw a new exception, and I'm calling the constructor there to make that new exception. Now Java underlined my code as red, and that's because I need to indicate that this exception can occur. I need to change my method header here to say that this method throws an exception, potentially. So once I've specified that in my method header, then I'm all set here. Everything's going to compile. And again, you can set the exception to occur for any kind of value that's out of range. Here I was just checking for if the credits were negative. I could also add a check in here that says if the GPA that they entered is in a good range. So if it's greater than or equal to 0 and less than 4.0, then use it to initialize the data field value. Otherwise, throw a new exception. That's just signaling that something bad happened, right? Something unexpected and weird happened in your method. You couldn't actually set up the student because their GPA that got passed to this method wasn't valid, or the credits passed to this method wasn't valid. So we've updated everything in our constructor. Now we need to come over and update our main program. That's because our student class now has the potential to generate that exception when we call the constructor here. So we have our choice as the person utilizing the class. We can either specify that instruction or we can catch that, we can either specify that exception or we can catch that exception. Specifying just means that you add the throws exception up here to acknowledge the fact that the exception might occur, and then that keeps the compiler happy. We know that if we run the program and we have a specified exception, oh, sorry, and we type in something that's not valid, like negative 100 credits, then it's going to generate that exception that got generated in our constructor. Then it got passed back to the main program, the place where the constructor was called. And then it printed out the call stack trace. So it's showing you here that we were executing the main program. We were executing the main program on line 17. That's the line that calls the constructor. And then in the actual constructor code on line 40, that's where the exception occurred. And sure enough, that is where the exception occurred. The credits were negative. So it threw the exception on line 40. So remember that call stack trace gives you the context. It's the sequence of methods that were called up to the line where the exception was generated. And of course, if I run the main program and I enter all good data, then I'm not going to generate the exception there. Then everything's just fine. It just keeps running on. And we've got our input here in a loop, so it's going to keep asking me for input. If I wanted to, I could, in my main program, use the try catch block around the constructor instead. That was kind of like what we did in the battleship program, right? whenever we called the board constructor, it had the potential to generate an exception. So we had to put the call to the board class constructor inside a try catch block. So if you want to generate an exception in your code, you're not sure what kind of exception it is, you can always use the generic exception. All the other exception types inherit from it. And so if a specific kind of exception occurred, it would still fit within that context. You can also make your own specialized exception classes. So if you want to make a special kind of exception, like if you wanted to make a GPA out of range exception, you could absolutely do that. You would inherit from the exception class, and then you would write your class as a subclass to that. You'll talk more about that in the object-oriented design class if you continue on and study Java for an additional semester. All right, I'm going to pause there and then I'm going to read the second question. Okay, the second question was about the string pair processing, the recursive problem that was in the final weekly coding practice. We worked together, we worked on that together in class on Monday, but just to repeat it for anybody who missed it, let me share my screen so we can all read it together. Again, this was the final part of weekly coding practice 13. It says that we are going to be processing some strings, some sequence of characters, and we're going to define a pair within that string as any two characters that match separated by another character, which may or may not match. So in other words, the sequence AXA, that is a pair of A's because there's two A's separated by a additional character. Or in this second string, AXA, there's three pairs. The first one is the first two A's. Those are a match separated by something else. And then the two X's, those are a pair separated by something. And then the final two A's, those are a third pair. So there's three pairs in that example. And the question says we should recursively compute the number of pairs in a given string. And then it walks us through thinking through the base case and recursive case. That's always the most essential part of solving any problem recursively. If you can identify the base case and you can identify the recursive case and you can write down in English what should happen in each of those cases, it's usually pretty straightforward to translate that into some Java code. Let's look at our examples down here and see if we can noodle out what would be a base case. So one thing I'm noticing as I look through here is that when I look at the expected input and the expected output here, there's like a couple cases where the answer is 0. So let's zero in on those. One example input where it gives an answer 0 is high. And that makes sense. That just has two characters in it. So there's no way that can have a pair because a pair has to have at least three characters, as says two matching things and then something in the middle. Similarly, this example down here where it has an empty string, there's no three characters in that. So the answer is always going to be 0. This example here just has a single character in it. That's going to have 0 pairs. And finally, this last example down here has 2 letters in it. That gives you a pair count of 0. There's not any possible pairs because there's not even 3 characters. So just thinking about the base case, if the string that we're looking at doesn't have at least 3 characters, then it has to have 0 pairs in it. So that's the base case. Then we want to think about what are the other things that could happen? What are situations where we have a string, it has at least three characters in it, and we want to indicate like how do we proceed to count up those pairs that possibly exist in there. We're going to look at recursive cases, cases where we have to do some more computation. And I'm going to identify two different recursive cases. One is when we have at least three characters. Um, and there is a pair at the beginning of the string. So in this case, there's a pair AXA, and then there's additional pairs in here too. There's B and B, and then C and C. So three total pairs in this string. We're just looking at this first part. The first three characters have a pair in them. And then another possible thing we could have would be for us not to have a pair in the first three strings or first three characters. So like AXY, there's no pair in those first three, but that doesn't mean there's not additional pairs in the string. There's still the B and the B are a pair, and the C and the C are a pair. So there's two pairs total in that one. So those are two different scenarios, two cases where we need to do additional work. In this first case, if we have a pair at the beginning, then we know we've seen one additional pair, or I'll say increase the pairs count by one. And then we want to keep looking through the rest of the string, excluding the first character, because there could still be additional pairs in this remaining character string. We just want to eliminate this first character, and now we want to continue looking in the rest of the string. You might not have realized it, but there is a method called substring. It's part of the string class, and it allows us to create a smaller string from an original string. So if we have this original string AX, A, B, C, B, C, and it has a name like S as the variable name, we could say we want to look at the substring of S starting at position 1. That would give us all the letters in the string except the original A. So if we find a pair at the beginning, we're going to count that as a additional pair, increasing the count by 1. And then we want to look for additional pairs in the substring starting at position 1. So that's going to be our first recursive case. And then finally, we have this last case. What if we have at least three characters and there's not a match at the beginning? Then we don't want to increase the number of pairs because we didn't find another one, but we do still want to continue to search for the additional pairs in the substring starting at position 1. So that'll be our second base case. So at this point, we've identified the base case and the recursive cases for this problem. We're ready to write the recursive method. So this method returns a double, the number of pairs detected. And it takes a string as the parameter. And then remember the code that goes inside your recursive method, it's always going to have an if-else structure. So we're going to say, if we're in the base case, do this. Otherwise, if we're in this first recursive case, do this. Otherwise, if we're in the second recursive case, do the third thing. So we're in the base case if the string S, the one that we're searching through, has a length that is less than 3. In that case, I want to set my counter to be 0. And now I'm going to program in the second case, the recursive case number one. That one is if the first character and the third character are a match. So if s.char at 0 is the same as s.char at 2, that means the first and the third character match. In that case, I want to increase the value of count. And I also want to, that's step one. I want to call the count pairs using the smaller substring. Oh, I should do that like this. So I want to set count equal to 1 plus whatever the result is from calling count pairs using s.substring starting at position 1. Oh, I was like, why is it telling me there's a syntax error? It's because it should return an integer. The count is an integer. All right, we're all good now. And then finally, my last case is going to be if the first two characters don't match. Again, that's the only remaining possibility there could be. Either there's less than 3 characters, or there are at least 3 characters and the first two match, or there are at least 3 characters. That's our last substring or our last recursive case. So I'm just going to have an else here, and then I want to return the count is count pairs using s.substring, running at position 1. And then at the end here, I want to return count. So I have my 3 scenarios covered. Let's write some code in main to test this out. So I'm going to make a little loop just so that it asks us for input repeatedly so that we don't have to rerun the program a whole bunch of times to test out different scenarios. So I'm going to say, give me a string. To test out. And then I want to call my count pairs method using that string. And then I should print it out so that I can see what the result was. I'm going to print string has pairs. All right. So again, I wrote the loop just so that it would make it easier to test things out so we could run it 10 different times and see 10 different outputs without having to recompile and run the program 10 different times. All right, so I'm going to pull up my example input so I can use that. So give me a string to test. So AXA. I'm expecting that to have one string. Yep. Or sorry, one pair. AX should have 2. AXBX should have 1. High should have 0. HIH has 3. IHIHH has 3. IHJXHH has 0. The empty string is going to be like hard to enter that because we didn't use next line. We could change that in the input. That's not a flaw in our recursive solution. That's a flaw in how we read the input. So I'm just going to move on to the next case. A, that has 0, AA has 0, and then AAA has 1. Super duper. And again, if I wanted to change that so that it worked with the empty string, I'd just have to change this to be next line instead of next. And it would work exactly the same. So AXA, that was the 2. That was the 3. That's the second 3. That one has 0. And then now if I press enter, it'll just read the empty string and it'll test that. It'll say it has 0 pairs in it. And then A, 2 A's, and then 3. That time I ran out of input options. That was the 11th test case, but I am confident it still works. It doesn't change anything to have used next line in our main program instead of next. So our solution for the count pairs method, again, what we did was set up a counter and set it to 0. If the string doesn't have at least 3 characters in it, then that means we're done. We should return 0 for that string. If there are at least 3 characters, we should check to see if the beginning is a match. And if it is, we'll increase the counter by 1. And then also add on to that the result of calling count pairs with the substring starting at position 1. It just lops off the first character in the string. And if the first 2 characters or first and third characters don't match, then we still want to continue searching in the string. We just don't need to update the value of count to increase it by 1. We didn't find a new string match in that case. And then at the end, we're just going to return the count. So that was the code for the recursive pair counting. That was the final part of week 13 coding practice. On Saturday, after all the final assignments are due, then I will post all of the code that we wrote together this week in class for the recursive solutions. That'll be in the code from class module on Canvas.